Hello viewers, welcome to my channel and thank you for watching the videos and subscribing the channel. इस वीडियो में हम जेकोबी मेथड करेंगे। इसका कॉन्सेप्ट चारपिट मेथड जैसा ही है। द ओनली थिंग द डिफरेंस इज वो दो वेरिएबल के लिए था, दिस इज फॉर 3 इंडिपेंडेंट वेरिएबल्स एंड फॉर मोर ऑल्सो। इसी को हम एक्सटेंड करके मोर वेरिएबल्स के लिए भी कर सकते हैं। ये मेथड सॉल्व करने के लिए, पार्शियल डिफरेंशियल इक्वेशन को सॉल्व करने के लिए 3 और मोर इंडिपेंडेंट वेरिएबल्स के लिए। इसका कॉन्सेप्ट जो सेंट्रल आइडिया है चारपिट्स मेथड जैसा ही है, क्योंकि चारपिट मेथड 2 इंडिपेंडेंट वेरिएबल के लिए, ये 3 एंड मोर इंडिपेंडेंट वेरिएबल के लिए है। तो हम 3 के लिए करते हैं एंड दैट कैन बी यूज्ड फॉर अदर 4 एंड सो ऑन। सो लेट P1 इज del z upon del x1, P2 is del z upon del x2 and P3 del z upon del x3। और हम पार्शियल डिफरेंशियल इक्वेशन जो लेते हैं f x1 x2 x3 p1 p2 p3 इज इक्वल टू 0। और इस केस में जो डिपेंडेंट वेरिएबल z है वो ऐसे नहीं अकर करता है, इट्स पार्शियल डिफरेंशियल कोफिशिएंट्स विद रिस्पेक्ट टू 3 इंडिपेंडेंट वेरिएबल्स x1 x2 x3 के रिस्पेक्ट में ही अपीयर करता है। सो z डज नॉट अकर एक्सेप्ट बाई इट्स पार्शियल डिफरेंशियल कोफिशिएंट्स विद रिस्पेक्ट टू 3 इंडिपेंडेंट वेरिएबल्स x1 x2 x3। और मेन आइडिया जो है जैकोबीज मेथड का, टू गेट 2 एडिशनल पार्शियल डिफरेंशियल इक्वेशंस ऑफ फर्स्ट ऑर्डर। सो वो पार्शियल डिफरेंशियल इक्वेशंस 2 पार्शियल डिफरेंशियल इक्वेशंस ऑफ फर्स्ट ऑर्डर ये ऑब्टेन करनी है। सो F1 कैपिटल F1 x1 x2 x3 p1 p2 p3 is equal to a1 and next is F2 x1 x2 x3 p1 p2 p3 is equal to a2, where a1 and a2 are arbitrary constants such that equation 1 2 3 can be solved for p1 p2 p3 in terms of x1 x2 x3, which when substituted in dz, which is equal to p1 dx1 plus p2 dx2 plus p3 dx3, ये इंटीग्रेबल हो and for which the conditions are there, that will be the condition. So are such that 1 2 and 3 are or can be solved for p1 p2 p3 in terms of x1 x2 and x3, एंड इसमें सब्सटीट्यूट कर देंगे एंड विच इज इंटीग्रेबल फॉर विच द कंडीशंस आर del p1 upon del x3 is equal to del p3 upon del x1 and del p2 upon del x1 is equal to del p1 upon del x2 and del p3 upon del x2 is equal to del p2 upon del x3. So these are the conditions. Now we differentiate equation 1 and 2. Differentiate equation 1 and 2 with respect to x1. We have del f upon del x1 plus del f upon del p1 upon del x1 plus del f upon del p2 upon del x1 plus del f upon del p3 into del p3 upon del x1 is equal to 0. And second, because here we are doing with respect to x1 and p1, p2, p3, x2 and x3 are constants. And next equation will be del f1 upon del x1, del f1 upon del p1 upon del x1 plus del f1 upon del p2, del p2 upon del x1, del f1 upon del p3, del p3 upon del x1 is equal to 0. So this is 4 and 5. We eliminate del p1 upon del x1. So this term is here and here. So what we do, we multiply this equation by del f1 upon del p1. And this equation by del f upon del p1 and then subtract. So this becomes first term del f upon del x1, del f1 upon del p1, and first of second, the equation 5. This is del f upon del p1, del f1 upon del x1, and second term will cancel out. Now third term, in third term del p2 upon del x1, this is common. Second term cancels out, third term common we take and then multiply. This is common, del f1, del f upon del p2, del f1 upon del p1 minus del f upon del p1, del f1 upon del p2 into del p2 upon del x1 plus third, this is common, so del f upon del p3, del f1 upon del p1 minus del f upon del p1 into del f1 upon del p3 is equal to 0. Similarly, we differentiate equation 1 and 2 partially with respect to x2 and eliminating del p2 upon del x2. So the same procedure we will be doing, and the term del p2 upon del x2 will come in second term, because in place of x1 in equation 4 and 5 everywhere it will be x2, and we will be eliminating this second term. So in that case we will multiply, say same numbers are there, equation 4 and 5, then we will be multiplying equation 4 by del f upon del P2, and then equation 5 will be del F upon del P2, and then subtracting. So we get the equations directly, we can write. So this comes del F upon del X2. In place of X1, X2 we can write del F1 upon del P2, because we are multiplying by this term now and this term, minus del F upon del P2 into del F1 upon del X2, plus this time from first term the common will be del P1 upon del X1, and we write del F, this term and this term multiplied by corresponding terms, del F upon del P1 into del F1 upon del P2 minus del F upon del P2 into del F1 upon del P1 into del P1 upon del X1, and second term won't be there, third term will give in this del P3 upon del X1. So in place of X1, X2 is there, so del P3 upon del X2 will be common, and we multiply respective terms by respective terms. So del F upon del P3 into del F1 upon del P2 minus del F upon del P2 into del F1 upon del P3, common is del P3 upon del X2, is equal to 0. Similarly, we can differentiate equation 1 and 2 with respect to X3 now, and eliminate del P3 upon del X3. So now third term will cancel out, and we will be, because we are differentiating with respect to X3, so X1 will be replaced by X3, and then this term will cancel out. So we will be multiplying by this term and by this term. So this comes del F upon del X3 into del F1 upon del P3 minus del F upon del P3 del F1 upon del X3. This is from first term. From second term, common will be del P1 upon del X3, and we will multiply by del F upon del P1 and multiply by del F1 upon del P3 minus del F1 upon del P1 and multiply we are doing by del F upon del P3. Order we can write it here, and common is del P1 upon del X3, and last term will cancel out. From second term, del P2 upon del X3 is common, and by multiplying, so we get del F upon del P2 into del F1 upon del P3 minus del F upon del P3 del F1 upon del P2, and common is del P2 upon del X3 is equal to 0. So these equations we got. This equation is 6, 7 and 8. So we add 6, 7 and 8 and use the conditions which we had written earlier, 3 conditions. which were that del P2 upon del X1 is equal to del P1 upon del X2, and del P1 upon del X3 is equal to del P3 upon del X1, and third was del P3 upon del X2 is del P2 upon del X3. So we will be using these. So adding equations 6, 7 and 8 and using the conditions, we can write del F upon del X1, del F1 upon del P1 minus del F upon del P1 del F1 upon del X1. So this is the first term of sixth equation 6. Similarly, first term of 7 and first term of 8 will be there, and when we see the second term of equation 6 and second term of equation 7, they will cancel out, because if we see their signs, they are opposite to each other. The second term of 6 is opposite to the second term of 7 in terms of sign, and coefficients, the common term is same due to the condition, so they will cancel out. Similarly, del P3 upon del X1 and del P1 upon del X3, these are equal, so third term of 6 and second term of 8 will cancel out, and similarly the remaining two terms, which is third term of second, that is del P3 upon del X2, will be equal to del P2 upon del X3. So the last term of 7 and last term of 8, they will cancel out. So first term of all the three equations we will get after adding them. So we will write that this is first of sixth, then first of seventh is del F upon del X2, del F1 upon del P2 minus del F upon del P2 del F1 upon del X2, and then the last third one with respect to X3, del F upon del X3, del F upon del P3, del F1 upon del P3 minus del F upon del P3 into del F1 upon del X3 is equal to 0. So this term, which is on left hand side of equation 9, generally denoted by this, is denoted by F1, because these are partial derivatives of F and F1. Which is equal to, we can write in terms of summation, sigma r is equal to 1 to 3 del F upon del XR, del F1 upon del PR minus del F upon del PR into del F1 upon del XR. So reverse is there. Here with respect to XR, then PR, in this PR and XR, F and F1, F1 and F1. So we have written F and F1. So similarly, F and F2 can be written sigma r is equal to 1 to 3 del F upon del XR, del F2 upon del PR minus del F upon del PR del F2 upon del XR, and this is equal to 0 and this is also equal to 0. And for third, F F3 sigma r is equal to 1 to 3 del f upon del xr del f3 upon del pr minus del f upon del pr del f3 upon del xr is equal to 0. So now these three equations, these are linear equations of first order with x1, x2, x3, p1, p2, p3 as independent variables and capital F1, capital F2 as dependent variables respectively. So independent variables are x1, x2, x3, p1, p2, p3, and dependent variables are f1 and f2. And for both of these equations, Lagrange's auxiliary equations are so we write down f1 f2 as it is. In place of small f we write capital F1. In place of f1 we say the first one, we write f2. So this expression, now as I said, ff1, ff2, ff3, these are linear equations, and x1, x2, x3 and p1, p2, p3 are independent variables, and f1, f2 are dependent variables. So we can write down for f1 and ff2 Lagrange's auxiliary equations. These are dp1 upon del f upon del x1 is equal to dx1 is equal to minus del f upon del p1 is equal to dp2 upon del f upon del x2 is equal to dx2 upon minus del f upon del p2 is equal to dp3 upon del f upon del x3 is equal to dx3 upon minus del f upon del p3. So these are called Jacobi's auxiliary equation, and we try to find out two integrals, and these two are independent integrals. These integrals are f1, x1, x2, x3, p1, p2, p3 is equal to a, and f2, x1, x2, x3, p1, p2, p3 is equal to a. So we solve them, and with the help of other auxiliary equations we find these integrals, and if these relations, we find these two independent integrals with help of Jacobi's auxiliary equations, and if these relations satisfy equation f1 f2 is equal to 0, then these are required two additional relations, 2 and 3. We mark them as 2 and 3 as we did earlier. Now we solve equation 1, 2, 3. For P1, P2 and P3 in terms of x1, x2, x3, and substituting these values in equation 4, and substituting these values in dz, p1 dx1 plus p2 dx2 plus p3 dx3, and integrate it, and then integrating the resultant equation. We will obtain a complete integral. So we shall obtain a complete integral of the given equation containing three arbitrary constants of integration. Now we do examples based on it.